Today we're going to be multiplying binomials. If you remember back to our last lesson, we were multiplying a monomial times a binomial, and we were using the distributive property. Today we're also going to use the distributive property, but you have to go through the distributive property twice. So we're going to use something that we call FOIL, which basically leads you through the distributive property twice. The way this works is we're going to act like this second term in our first binomial does not exist, and we're going to use the distributive property here. When we do our x times x, we call that first terms. We're multiplying the first term in the first binomial times the first term in the second binomial. That's x times x. Then we're going to do the outer terms, which is the second part of our distributive property, which is x times negative 5. Technically, this should say plus 5. Okay. Then we're going to multiply. We're going to act like the first term does not exist, and we're going to do the distributive property with the second one. So this is called inner terms. The 2 and the x are the inner terms. So we have plus 2 times x. And then we're going to do the last terms, which is 2 times negative 5. When we combine this together, back up a step here. We're going to get x squared minus 5x plus 2x minus 10. If you'll notice here in the center, you have something that we refer to as like terms. When we have like terms, we have to simplify that by combining them. So when we do, we're going to, the negative 5x and the plus 2x becomes a negative 3x. And when we multiply the two binomials, it became a quadratic trinomial, x squared minus 3x minus 10. Another example, we're going to practice this again. We're doing FOIL, or the distributive property, twice. So in the first, we're going to do the first terms, which gives us a 3a squared times a squared. And then we're going to do the last, or the outer terms, pardon me. And when we do that, we're going to be, this would be a plus sign. We have a 3a squared times a negative 2b. Then we're going to do the inner terms, and we're going to multiply a negative b times an a squared. Then we're going to do the last terms, and we're going to multiply a negative b and a negative 2b. When we do that, we get 3a to the fourth. When we multiply 3a squared times negative 2b, we get a negative 6a squared b. When we multiply negative b times a squared, you could write negative b a squared, but if you do that, if you look back right here, these are actually like terms, and we do not recognize them as like terms unless we write them the same way. So if you always write them in alphabetical order, so instead of writing negative b a squared, if we write negative a squared b, you would be more likely to recognize these two as like terms. So we're going to write that as negative a squared b. And then two negatives make a positive 2b squared. Again, here in the center, you will recognize that we have like terms, and our visible one in front of this will result in a final answer of 3a to the fourth minus 7a squared b plus 2b squared. FOIL, distributive property twice, is what we're doing. This is another way that some people look at it. It leads you through the same process, but it does it with the multiplication square. So when you have something like this, you could put the binomial on the top, one horizontal, one vertical. So to get this box, you're multiplying 3a times a squared, which was 3a to the fourth. To get this box, you're going to multiply the negative b times the negative a squared, which is a negative a squared b. To get this box, you multiply the negative 2b times the 3a squared, which is a negative 6a squared b. Again, writing your variables in alphabetical order. This box is the result of negative b times negative 2b, and that results in a positive 2b squared. And again, you're going to have your like terms right here. This is just another way to organize it. It's the exact same problem that we just did. It's just doing it with squares, and some people like organizing it this way. And if you do, you can set one up vertically and one horizontally, and then look for the like terms in the end, which are right here, and you combine them and you end up with the same answer. This right here confuses some people. This says x plus 5 squared. It's in parentheses. So what that means is we have the binomial x plus 5 times the binomial x plus 5. Now we would do the FOIL, or the distributive property, twice, and we would multiply the x times the x, which is x squared, the x times the 5, which is 5x, our inner terms, 5 times x, which is 5x, our last terms, which is 5 times 5, which is 25. Again, you have your inner terms right here that are like terms, and our result is x squared plus 10x plus 25. We also are going to be multiplying binomials times trinomials. I'm going to show you two different methods of doing it. If you're taking the notes, one of the ways you're going to show on the left side of the line, and the second way you can show on the right side. You can decide which way you like to organize it better. The first way I'm going to show you is just doing the distributive property twice. Again, we're going to act like this term does not exist, and we're just going to do the distributive property like this. At first, we have x times x squared, which results in x cubed. Then we have x times a negative 5x, which results in a negative 5x squared. Then we have x times 4, which results in a 4x. Now, when we get ready to do the next part, and we're going to multiply the 2 times all three terms over here. As we do this, we're going to stack them with like terms with the first one. Let me show you how that works. The 2 times the x squared, we have 2 times x squared, which results in 2x squared. I'm going to organize it right here. I put it underneath my other x squared term because I'm going to have to combine my like terms at the end. So I'm just organizing it as I go. Next, we have a 2 times a negative 5x, which results in a negative 10x, and I'm going to put that right here under this x term from the previous distributive property. And then at the very end, we have 2 times 4, which is 8. And it's going to go over here. And as I do this, you'll notice, since we have to combine our like terms, they're already lined up really nicely for me. So my final answer would be x cubed minus 3x squared minus 6x plus 8. So that is one way that you can do a binomial times a trinomial. If you remember back to elementary school, you may have done double-digit multiplication. Surely you did. If you remember doing this, you would multiply 5 times everything on top. And then you would put this placeholder 0 here, and then you would multiply 4 times everything on top. We're doing the same thing here. We stacked it. We put the trinomial on top times the binomial. First thing we're going to do is just multiply the 2 times everything on top. So first we do 2 times 4, which is 8. 2 times a negative 5x, which is negative 10x. 2 times x squared, which is 2x squared. Now next, we're going to multiply x of the binomial times everything on top. So when we do the x times the 4x naturally lines up, because remember we always have this little placeholder 0 right here. It magically lines up our like terms right here so that they're lined up just like we had in the last example. When we do our 5 times our negative 5x times x, there's that negative 5x squared that lines up right under the other x squared term. And then we have x times x squared, which is x cubed. And it magically lines all of the like terms up so that when you combine them, you get the same answer. So that's two different ways that you can do a binomial times a trinomial. Good luck with multiplying binomials.